In this tutorial, I'm going to show how to use the Processing Raw Data menu. This menu is going to help processing DNA methylation data. So our raw data is actually IDAT files from microarray. I'm going to just select a small example. I have one here with two samples from 450K platform. So we have both channels, green and red. Then we use this MIF package from Bioconductor to read those files. And the platform and the genome of reference is automatically identified. So for this example, we have our two samples, both from 450K platform, and the genome of reference is the 1819. Then the next step is going to normalize that data. We use mainly MIF to do that. We mask the probes that the detection p-value is higher than 0.005. That's our threshold. We do the new pre-processing step from MIF, and then the probes that overlap SNPs are masked. This information is retrieved from the mask information for SNPs retrieved from Peter Laird group. So they have this GitHub website where you can download the annotation with the suggested overall masking. So that's what we're doing. After doing the normalization, it's going to save into the object, into a summarized experiment object, which can be viewed in the Manage Summarize Experiment menu. So we're going just to select the file we created. And the Summarize Experiment object has several matrices. One is the one that has metadata for our ranges, which are our probes. So it's going to give us the name of the probe, location, start end, chromosome. And we have also the assay matrix, which contains the data itself. So for the DNA methylation, the beta values. 0 means unmethylated, 1 means methylated. If it's empty means it's Na, so it was masked by some reason. So this is our beta values. Using this object, we are going to classify it into glioma molecular subtypes. So we have this menu called classifier, and there is the submenu glioma classifier. So just to explain, there is this paper called Molecular Profiling Reveals Biologically Discrete Subsets and Pathways of Progression in Diffuse Glioma that identified 7 molecular subtypes based on DNA methylation data. And this paper provides 4 probe signatures that is going to help us identify which of those 7 a new sample would be. So what we have done is we got those signatures, we got the samples and their labels. So these steps are actually described in our JBiolinks GUI data package. So if you go to the vignette, we have all the steps and all the code we used to create this object. So we got all those signatures. For example, we have a signature that's going to identify, that's going to classify our object between IDAT mutant or wild type. Using those probes, it's going to classify between the 6 groups, and which is actually shown here. So LGM 1 up to 3 are IDAT mutant, 4 to 6 wild type. So we have 4 training models from that we used the random forest algorithm to create them. So the steps are quite simple. We just select our summarized experiment. and then we just classify it into our molecular subtypes. So for each training model, we have the results. So the first step identifies between, which defines between IDAT mutant or wild type, defined as wild type. So we went to this side of the tree. So the other side we're not going to evaluate. And the next question is, if it's wild type, which of these groups? Which molecular subtype it is, and it falls to BA-like. So our two samples here are BA-like.